with. This one is brand new and its parts are clean. When you're doing safety valve maintenance, the step after disassembly will be cleaning all the parts thoroughly. This can be done at a cleaning station using solvent and a brush, or it can be done by dipping each part directly into solvent. In either case, be certain to use a solvent recommended by the manufacturer and get all the parts as clean as possible. Clean parts are easier to inspect and they fit together better when you reassemble them. After cleaning, inspect each part carefully. The 4 parts that deserve the most careful inspection are the feather, the seat, the adjusting rings, and the spindle. Let's consider each one in turn, identifying some common types of damage you're likely to see, and discussing what to do when you find a part that's worn or damaged. We'll start with the feather. When inspecting the feather, the first thing to look for is cracking. Even the smallest cracks are serious, and a cracked feather must be replaced with a new one. Steam cutting is another common problem with feathers. If the damage is this bad, your supervisor will probably recommend that you replace the part. If the steam cutting is relatively minor, you can usually restore the damaged surfaces by lapping them. Because this feather is flat, it can be lapped on a lapping plate. A layer of lapping compound on the plate provides the abrasive required to restore the surface of the feather. If the damaged feather is round or cone-shaped, it can't be lapped the way a flat feather is. Your text gives information on how to repair feathers of various shapes. Another part of the valve that's subject to cracking and steam cutting is the seat. As we saw during disassembly, the seat in this safety valve is a permanent part of the valve body. If it were damaged as seriously as the one you see here, you'd have 2 choices. You could use a special tool specifically designed to restore the damaged surface, or you could mount the valve in a lathe and remachine the seat. Both procedures are discussed in your text. If the seat has only minor damage, lapping is the best solution. Lapping a seat requires special care. So let's take a few minutes to watch the mechanic demonstrate the proper procedure. Just keep in mind that the seat in this valve is flat and a part of the valve body. The procedures for lapping other types of seats can be found in your text. To begin, he needs a lapping block and 1 or more types of lapping compound. Because the valve is new and this is only a demonstration, he'll use a very fine lapping compound. If the seat were actually steam cut or nicked, he would use more than 1 type of lapping compound. He'd begin with a coarse compound to quickly remove most of the damaged metal. Then he'd use progressively finer compounds to ensure a flat surface. He begins by putting a few dabs of compound on the face of the block. Then he places the block on the seat and begins lapping. The abrasive compound between the block and the seat wears down the surface of the seat so that it conforms to the perfectly flat surface of the block. It's not necessary to exert any downward pressure on the block, but it is necessary to move the block in a smooth, regular motion. As you can see here, the mechanic alternates between a figure 8 motion and a circular motion. When he feels that he's achieved a smooth, flat surface, he removes the lapping block and cleans the compound off of it. He then uses solvent to rinse the compound off the seat and other internal surfaces of the valve. He wipes away all remaining residue with a clean cloth. A flashlight helps him to inspect the seat for any nicks or uneven spots. If his inspection showed any irregularities, he'd have to continue lapping until they disappeared completely. Now, there's one thing to keep in mind regardless of what type of seat you're lapping. Because the lapping process removes metal from the seat, it's likely to change the set points of the valve. So, when you reassemble the valve, you'll probably have to compensate for this change by adjusting the compression screw and the adjusting rings. Again, you'll find more information about this in your text. Okay, that covers inspection and certain types of maintenance of the feather in the seat. Now, what about the adjusting rings and the spindle? Well, the adjusting rings are subject to nicks, cracks, and steam cutting just as feathers and seats are. But such damage is less likely in adjusting rings. Nonetheless, the rings must be inspected carefully to ensure that they won't fail during normal valve operation. If you find a ring that's damaged, it's usually best to replace it. That brings us to the spindle. The spindle is among the most critical parts of the valve. It's also one of the most likely to be damaged. The most common type of damage to the spindle is bending, caused either by careless handling or by system pressure pushing upward when the valve opens. A bent spindle can lead to a serious valve malfunction. It can prevent the valve from opening, or it can prevent open valves from reseating when system pressure drops back to normal. To avoid such mishaps, manufacturers establish strict specifications for spindles. Depending on the size and the type of the valve, a spindle might be unacceptable for use if it's bent as little as 1 1/2 thousandths along its entire length. The most reliable test of the trueness of the spindle is a run-out reading. The run-out reading is an essential part of any safety valve overhaul, so it's a good procedure to see demonstrated. During disassembly, the mechanic put the spindle on a pair of V-blocks, so he already has a head start on setting up for the test. The instrument he'll use is a dial indicator mounted on a magnetic base. He sets the base beside the spindle and secures it in place. He presses the stem of the indicator against the surface of the spindle until the stem retracts about 1/4 of its length. He then sets the indicator so that it reads 0. Zeroing the indicator gives him a reliable reference point for taking the reading. Being careful not to bump the spindle or the indicator, he rotates the spindle very slowly, keeping his eye on the dial. Any change in reading indicates an irregularity in the shape or the straightness of the spindle. In this case, he gets a run-out reading of about 1 1/2 thousandths. The spindle is slightly bent, but it's still within tolerances. This spindle, then, can be reinstalled in the valve, but if it didn't meet specifications, it would have to be replaced. And before a new spindle is installed, its run-out must be checked to be certain it's within specifications. Of course, the spindle should also be inspected for cracks and other signs of damage. It's especially important that the end that fits into the feather be smooth and round. You see, this end acts like a ball bearing inside the feather, enabling the spindle to adjust when the feather lifts unevenly. Flat spots on this end can cause uneven contact and unwanted friction between spindle and feather. In this segment, we've looked at 4 important parts of a safety valve. We've seen some types of wear and damage that you should be on the lookout for, and some procedures to follow to correct such problems. But don't get the idea that the feather, the seat, the adjusting rings, and the spindle are the only parts of the valve that require careful inspection and maintenance. They're not. For a valve to function properly, every part has to be in top working order, and the only way to make sure of that is to inspect each part and inspect it carefully. So, before we go on to reassembling this valve, turn off the tape and read section 3 of your text. There's a lot of information there that's essential for you to know.